Before I start, let me first apologize if I start coughing. I've been battling a sinus infection, and when I talk, I start coughing. But I need to get this video out there for my students. So this lesson is on solving multi-step equations. And any equation that takes more than 2 steps to solve, we just call a multi-step equation. So let's go over, excuse me, a few basic rules. So the first rule, or the first step is, if you see distributive property in the equation, meaning, so let me give you an example again of what that would look like, a number outside of parentheses or a variable outside of parentheses, and inside of the parentheses are 2 or more things being added or subtracted together. All right, that's distributive property. And we're going to do this, but just remember that you multiply everything inside the parentheses times whatever's outside the parentheses. So that would be step 1 in a multi-step equation. Step 2 then would be to combine any like terms. So there might not be distributive property and there might not be combining like terms. Okay, that's why it says if necessary. So if you see distributive property, do it first. Then if you see any like terms you can combine those together. Now the key thing with combining like terms is they have to be on the same side of the equal sign. So if you had something like this, 3 plus 2x equals 8. 3 and 8 are like terms, but you can't combine those together because one's on the left side of the equal sign, the other one's on the right. But these x's you could combine together because they're on the same side of the equal sign. So we could combine those together to make 4x plus 3 equals 8. Okay, so to combine like terms, they have to be on the same side of the equal sign. They could be on the left or they could be on the right. And then the third thing is, once you get to this point, you should now just have a 2-step equation. So you just solve it. If you're not familiar with solving 2-step equations, you should probably review that before tackling multi-step equations. So let's look at an example. So step 1 is distribute if necessary. There's no distributive property involved here. So we move to step 2, is excuse me, to combine like terms. And so if I look on the right side of the equation here, I have a 5m and a 2m that I can combine together. So I'm going to combine the 5m and the 2m. Now remember, the symbol in front of a number or variable belongs to it, and it tells us how to combine these. So this is 5m plus 2m. So when we combine those together, we'll get 7m minus 23, and on this side we have the 5 still. So now we're on to step 3, and like I said, now we have a 2-step equation. So now we just solve for the variable by using opposite operations. Remember, we do the adding or subtracting first. So I see a minus 23. So to get rid of that, again, the whole point is to get the m by itself. I'm going to add 23 to both sides. When I say both sides, I mean both sides of the equation, or both sides of the equal sign. Minus 23 plus 23 is 0. 5 plus 23 is 28. So now I have 28 equals 7m. So 7 times m, so I do the opposite of what I see, and I do division, so I divide both sides by 7. 7 divided by 7 is 1, so that's going to cancel out because 1m, about that, I don't know what this thing is doing. 1m is the same thing as just m. And on the other side, 28 divided by 7 is 4. So I get 4 equals m, but in algebra, we prefer that you would write it as m equals 4. So flip it around. And remember, you can always go back and check your work when you're solving equations. So I can see is 5 times 4, because I said m is 4, minus 23 plus 2 times 4 equal to 5. So you can do 5 times 4 minus 23 plus 2 times 4. make sure you follow PEMDAS and do the multiplication first. So I have 20 minus 23 plus 8. 20 minus 23 is negative 3 plus 8 is positive 5, which is what this was supposed to be equal to. So I now got the correct value for M. All right, let's look at a word problem, everybody's favorite. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. If Martha's total is $67, what is the cost of 1 shirt? So when I do these, I like to first determine what are my variables. Sometimes there's 1, sometimes there's more than 1. All right, the easiest way to find your variables is to look for question marks, because the variables are usually what you're trying to find. And so usually there's going to be a question asking you what is the value of the variable. So here's my question mark. It says if Martha's total is $67, what is the cost of 1 shirt? So I'm going to use S for cost of a shirt. So that's our unknown. Now you might say, what about the bumper stickers? Isn't that a variable? And the answer is no, because they tell us right here that the bumper stickers cost $1 each. So that's why it's not a variable, it's a known value. All right, so now let's move on to the equation. In equations, I always like to start with the end. What do I mean by that? Well, in an equation, you're going to have some situation here that's described, and it's generally going to be equal to some value. So I like to figure out, what is this whole thing equal to? So if you look here, it says if Martha's total is $67, that's the result of this whole situation, is the $67. I'm going to start with that, and then I'm going to fill in this piece just by writing the information that they give me. So it says Martha's niece wants 1 shirt. Okay, so we got 1 S and 4 bumper stickers. Well, the bumper stickers are $4, so I can just say plus 4, and this is dollars. If you want to put a dollar sign there, that probably might be helpful. And then her nephew wants 2 shirts. Okay, so the nephew wants 2 shirts and no bumper stickers. So this is all that she bought: a shirt for her niece, plus 4 bumper stickers, plus 2 shirts for her nephew, and that total is $67. So our equation is S plus 4 plus 2S equals 67. So now we go through our steps. Now keep in mind, a lot of times they're going to ask you 2 things. In this question, it just said, what is the cost of 1 shirt? A lot of times they'll say, what is the equation that represents this? And so the equation that represents this would be this right here. Okay. And then my student's assignment, there's going to be 2 parts. It's going to ask for the equation, and then it's going to ask you to solve it. So in the first part for the equation, this is what you would write: S plus 4 plus 2S equals 67. And then to solve, we come down here and solve this. Now we're going to go back to those steps. So S, that's an ugly S, plus 4 plus 2S equals 67. Step 1 was to distribute if necessary. There's no distributive property here. So I go to step 2, which is to combine like terms. So I can combine the S and the 2S to make 3S plus 4 equals 67. And now I just have a 2-step equation to solve. So I'm going to use opposite operations to solve for the variable and get it by itself. Again, the whole point of this is to find out, what is S equal to? What is the cost of a shirt? So I see plus 4, I do minus 4. You always do the adding or subtracting first. So 4 minus 4 is 0. So now I have 3s equals 63. I see multiplication, so I do division. Divide both sides by 3. 3 divided by 3 is 1, and 1s is the same thing as just s. And 63 divided by 3 is 21. And so in this case, the answer to the question is that a shirt costs $21. All right. So here's another multi-step equation. Step 1, distribute if necessary. This one, we do need to distribute. So that's what we're going to do first. So negative 8 times 2x is negative 16x. Remember, when a negative comes in with a minus, when these two symbols come in together, it's always going to make a plus. So minus and negative is the same thing as plus. So the negative 8 times the minus 1 comes out to plus 8. And again, now I have a two-step equation. Do the adding or subtracting first. So I see plus 8. I do minus 8. So those cancel out. That's 0. Negative 16x equals negative 28. I see multiplication, so I do division. Remember, when you're multiplying or dividing, if this is a negative, you need to use that negative so that they cancel each other out. A negative divided by a negative is a positive. So that cancels out and leaves me with 1x. Negative divided by negative is a positive. I'm just going to write this as 28 over 16. Or why I wrote 26. So 28 over 16. It's okay to leave your answers improper in algebra. Excuse me. Sorry. But you do need to make sure it's simplified. So these are both even numbers. So I know it's divisible by 2, but is there a bigger number? Well, 16 has factors of 8 that won't go into 28. It's also got a factor of 4 that will go into 28. So we're going to divide both of these by 4. Divide by 4, divide by 4. And we get x equals 7/4. Again, it's improper, but that's okay. Leave it that way. Again, I could check this. This one's not quite as much fun to check. But we're going to see, is this, when I substitute in 7/4, equal to 36? So I have 7/4. Rewrite this in the it's 2 times x. So 2 times 7/4 minus 1. All right, so 2 times 7/4, that would be 14/4 minus 1. You can distribute here, or you can do 14/4 minus 1. Do it either way. Let's distribute. No, I'm gonna subtract these. So I got to get a common denominator. So I'm gonna rewrite the 1 as 4/4. So negative 8 times 14/4 minus 4/4. So 14/4 minus 4/4 is 10/4. So now I have negative 8 times 10/4. Remember, you just put the negative 8 over 1 and multiply straight across. You can make your life a little simpler here, because these diagonals can be simplified. When you multiply fractions, you can always simplify the diagonals. Okay, so that becomes 1, that becomes 2, and it looks like I made a mistake somewhere. Because that comes out to negative 20, and it was supposed to come out to 36. So let me pause this and see where I messed up. All right, so this is a good why you should check your answers. So I looked over this and figured out where I messed up. 36 minus 8 here is positive 28. Okay, so 28 divided by negative 16, negative here. So this comes out to negative 7/4. So when I do this, multiplying this by negative 7/4, that would be negative 14/4. So negative 14/4 minus 4/4, negative 18/4 here. And then let me put the negative in here. Change this to 18. And now when I multiply this, a negative times a negative is a positive, and 2 times 18 is 36. So back here I had 36 minus 8 was negative 28. It should have been positive 28. And that's why we check our work. So I could have just started this over and had you not see my mistake, but it's probably good for you to see that. All right, so let's look at this type of equation. This is a little bit different. I'm going to show you two different ways that you can solve this. So the first way that you can solve this is by getting common denominators. Just like you would do whenever you add or subtract fractions. Common denominators. So you have denominators of 4 and 3. So the least common multiple of 4 and 3 is 12. So to change this into 12, I'm going to multiply it by 3. If I multiply the denominator by 3, I have to also multiply the numerator by 3. And over here, I'm going to multiply the top and the bottom by 4. So that's going to give me 9x over 12 minus 4x over 12 equals 10. And then I'm going to bring this together, and I'm going to write it like this. 9x minus 4x over 12 equals 10. Now from here, I did a previous lesson where I showed how to solve an equation that looks like this. Do that is by getting rid of this denominator, making this so it's not a fraction. And the way we do that is by multiplying both sides by whatever this number in the denominator is. I'm going to multiply this side by 12. I'm also going to multiply this side by 12. That will allow me to cancel out these 12s, cross simplify to 1 and 1. And so then what I get is 9x minus 4x equals 120. Combine like terms, 9x minus 4x is 5x. And then divide both sides by 5. Give myself a little more room here. 5 divided by 5 is 1. 1x is the same as x. And 120 divided by 5 is 24. So x equals 24. Now let me show you the other way to solve this. And you can choose either way. So 3x over 4 minus x over 3 equals 10. So this way is to multiply both sides by the common denominator. So multiply both sides of the equation by the common denominator. All right, so we said the common denominator would be 12. Now, here's the key. When I multiply, so I'm going to multiply both sides by 12, okay? When I multiply this side of the equation by 12, I need to use parentheses. I'm multiplying this whole side by 12. So not just one of these, but both of these. So that's going to be the distributive property here. Okay, so I'm going to multiply both of these by 12. I'm going to write this out long ways, okay? And you'll see why. 3x over 4 multiplied by 12 over 1 minus 12 over 1 times x over 3 equals 120. Now, when we multiply by the common denominator, what it allows us to do is cross-simplify and eliminate the denominators here, and therefore eliminate the fractions. So I can cross-simplify this. 12 and the 4 be simplified to 1 and 3, and the 12 and the 3 here can be simplified to 1 and 4. So now when I multiply these together, 3 times 3x is 9x, and that was just over 1, so I don't need to, I basically got rid of the fraction, and then 4 times x is 4x. And now you see I ended up at the same place that I ended up here. So I don't know which method you think is easier. They're really pretty about the same difficulty, same number of steps, but it's up to you. You might like one better than the other. So again, 9x minus 4x is 5x. And then you divide both sides by 5. And you get the same answer, x equals 24. So you might want to back that up and watch that again to understand both of those methods. All right, here's the last one. The last one is an equation that involves decimals. And a lot of times when we have equations involving decimals, we'd like to get rid of the decimals because it makes the work easier. Now, if you have a calculator, it doesn't really matter if you get rid of the decimals or not, but if you didn't have a calculator, your life would be a lot easier if these didn't have decimals here. So here's how you do it. It says find the number with the most digits after the decimal. Okay, well that's this number, right? 0.02. Then multiply both sides of the equation by the place value of the last digit after the decimal. So this last digit is in the hundredths place. Hundredths. So we have tenths, hundredths. So what we're going to do is multiply both sides of this equation by 100. And that is going to clear the decimals, all of them. So I multiplied this by 100 because the last number after the decimal is in the hundredths place. Now, here's a cool trick. When you multiply a number by 100, all you have to do is move the decimal point 2 places to the right. This always works. So just a real simple example. If I was multiplying 1 times 100, okay, the 1 has a decimal point right here. Move that decimal point 2 places to the right, and you get 100. 1 times 1,000 is 1,000. All you have to do is move the decimal point how many places to the right that there are decimals here, zeros here. So if you're multiplying by 1,000, you'd move the decimal point 3 places to the right. Multiply by 10,000, you'd move it 4 places to the right. So when I multiply these by 100, and again, this is distributive property here, doing this to everything in the equation on both sides. So 3.5 times 100 is 350. I don't want to use that color, sorry. 3.5 times 100 is 350 minus, move the decimal point 2 places to the right, and you get 2x. And 124 times 100 is, 1.24 times 100 is 124. Move the decimal 2 places to the right. And I kind of misspoke earlier. I didn't realize I did this. I said that this number had the most digits after the decimal. It actually was a tie with this one. This one also had 2 numbers after the decimal. All right, so it doesn't matter if it's on the left or the right side. It's just a question of how many places do you need to move the decimal to clear all the decimals out. The furthest I need to move it is 2 places. So to move it 2 places, I multiply by 100. So what we have now is equivalent to what we started with. Remember, you can do anything you want to an equation as long as you do the same thing to both sides of the equation. And then the equation will still remain true. All right, so now I just have a 2-step equation. So adding or subtracting first. A lot of times my students will want to subtract 350 here because of this minus sign. That minus sign belongs to the 2x. This is a positive 350. So to get rid of that positive 350, you want to subtract 350. So 350 minus 350 is 0. Now this minus sign belongs to the 2x. It doesn't just disappear. So it needs to come down with the 2x. And then 124 minus 350 is negative 226. And I do 5. Limit on my sinus infection. Why not? Now I have negative 2 times x. So I want to divide both sides by negative 2. Negative 2 divided by negative 2 is positive 1. 1x is the same thing as x. Negative 226 divided by negative 2 is positive 113. All right, so I know that was kind of long. Hopefully that was helpful to you. If so, give it a like and a subscribe, and please feel free, excuse me, please feel free to leave me a comment. And hopefully next time I make a video, I won't be coughing. Till next time.